Okay, so go ahead and find this order of operations with sign numbers page, and then let's talk about it. Really, when we're doing order of operations and we have positives and negatives, nothing is really going to change from what you've done in the past here. It's just kind of we're practicing the same skill we've done using now what we know about adding, subtracting, multiplying, and dividing when you have negative numbers. So, first thing that I put on here for you, I'll zoom in a little so you can see, is just the rules for integer operations, right? So when we add, if the signs are the same, we add the numbers and keep the sign. If the signs are different, we subtract the numbers and use the sign of the larger number. For subtraction, this particular thing uses keep, change, change. We talked about same, opposite, opposite. So whatever makes sense to you there. And then once we do that, because it's addition, then we go and use the same addition rules. And then for multiply and division, we know that the answer is to multiply or divide like regular. And then if they say have the same signs, the answer is going to be positive. And if there's different signs, the answer is going to be negative. The other thing to remember are the rules for order of operations. So the steps we have to take in which order. And so people usually remember this with PEMDAS. You can come up with your own words that go with each of the letters. The more traditional one is please excuse my dear Aunt Sally. But, whatever works for you. If you see something that comes out with the letters that's better, then use that to help yourself. So when you see the P is for parentheses. The and parentheses also is any other kind of grouping type symbols. So eventually you'll see some different ones in math there, and that kind of falls in there. So some people call this GEMDAS with the G for grouping symbols. The next part is exponents. You talked about exponents last year in math. We haven't talked about it a ton yet this year. So remember that an exponent has a base and an exponent, and it's multiplied that factor the number of times of the exponent. So for example, when you have 3, and I'll press this button, shift and the number 6 to the third, usually we see the little 3 up there too, so we could also do that. Let's do 3. Let's actually change this and do 2 to the third. What that means to do, and I'll make this box a little longer here, is to do 2 times 2 times 2. So the number 2 gets repeated, the first thing there, and then the little number is how many times. And so 2 times 2 times 2 means to do 2, which is not 6, by the way. It's 2 times 2, which is 4, and then 4 times 2, which is 8. So remember that with exponents. That kind of messes us up sometimes. Then the M is for multiplication. The D is for division. And when we do multiplication and division, see how they both are kind of together in green in this picture? That's because it's not that multiplication comes before division. It's whichever one comes first. So we go left to right. So you could do divide and then multiply and then divide, or you could do multiply and then divide, however you see it from left to right. And then the A and the S are similar also. Notice they both are in yellow there. A is for addition, and S is for subtraction. And again, you go left to right. Now, with your calculator, depending on what kind you're using, depends on if it knows order of operations or it doesn't. If you are using a scientific calculator, so that looks like that TI-30X kind of a thing there, right? Those kinds of calculators know order of operations. So it already knows that you're supposed to do multiply before you do add. But if you're using, say, like just the calculator from the computer, not a scientific one, or you're using just like ones that have add, subtract, multiply, divide, and no other buttons on it, or even often on your phone, if you're using that calculator, it doesn't know order of operations. So this is something you got to be really careful about, is kind of knowing the limitations when you're using calculator. So we're going to go ahead and try these steps here. We have two problems, and I want to be able to write on them. So I'm going to right click, save to keep, open it in the new tab. Click it again so the little pen comes. And then we'll be ready to do that. Oop, my dot's way too big. Let's make it a little smaller and do it in red, that's fine. Okay, so when I do order of operations, I have to kind of go through and do my steps, right? So first thing I'm looking for is parentheses. And this problem has no parentheses. So I skip to the next step. Next one is exponents. On here, I do have an exponent. So that's the very first thing I'm going to do is this. This is still a little big. Okay. And so then I'm going to write everything that's already here. But instead of 2 to the second power, the exponent there, I'm going to write its answer. So we didn't do anything with -4, so I still write -4. Divide by, still got that. Then 2 squared means 2 times 2, which is 4. And then I still have +3, and I still have -10. Those things didn't change. Okay. So parentheses I did, exponents, I could look and see if there's any more. There's not, so I'm done with that step. Then I have multiply, divide, whichever one comes first. So this problem has a divide, no multiply. So I'm going to do my divide. And again, I'm kind of using this to show which numbers I'm doing. So -4 divided by +4. The signs are different. So that means it's going to be a -1. And then I still have +3. And I still have -10. So I was at the multiplication and division. I don't have any more multiply or divide. So now we've got addition and subtraction, and whichever comes first. So in this case, the addition comes first, so I'm going to do that one first. So I have -1 plus 3. Signs are the same, which means that signs are different, which means that I subtract. And the bigger one's positive, so it's going to be a +2. So this would be a great example of why being able to do this without your calculator is super helpful, because this would take you a lot longer if you had to keep typing these in. Then I only have one step left, so that must be the one I have to do, which is 2 minus 10, right? And we know that 2 minus 10, I could kind of write this over to the side, right, is the same thing as 2 plus, the opposite of 10 would be -10. And then signs are different, so I subtract, and 10's the bigger digit, and it's negative, so -8 is my final answer on that problem. Next one, similar idea. I'm going through all my steps here. It's just got a couple more in there. So I go back to the beginning, P for parentheses. This one does have parentheses, so that's the first thing I'm going to do. I didn't touch the 18, so I'm going to keep it. I didn't touch divide, or the 3 squared, or the plus, or the -8, or the minus. I'm just going to do -3 minus 2. So if I kind of put that to the side for myself, I know it's the same as -3 plus -2. Then the signs are the same, so I'm going to add, and it's going to be negative, so -5. If you want to put parentheses so you don't lose a sign, you can. You don't have to, because sometimes in order of operations that confuses us. Looking here, I don't have any more parentheses. So my next step was exponents. So I do have one of those. So that's what I'm doing next. So 18 stays 18. Divide is still divide. 3 squared does not mean 6. It's 3 times 3, which is 9. And then I still have plus -8 minus negative 5. So I have no more exponents. So then I'm looking for multiplication or division, whichever comes first. And I have division. 18 divided by 9 would be 2 plus negative 8 minus negative 5. Then I don't have any more multiply or divide. So my last thing is add or subtract, whatever comes first. In this case, it's add. So 2 plus negative 8 would be, signs are different, so I subtract. And 8 is the bigger digit, so it's a negative. And then I still have minus negative 5. And then last but not least, I got this problem right here. Again, I'll kind of go and change it to addition. So I have negative 6 plus positive 5. Signs are different, so I subtract. The 6 is the bigger digit, so it's a negative 1 for my answer. And that's the idea of how that works. So I'll go ahead, go back, and we can go in here, delete this one, and then I can copy and paste my work into here so I have it as an example for myself. So remember, nothing necessarily new. You're just using your PEMDAS with your integer rules.